Welcome. In this video, we'd like to show you how to calculate your transport equipment using emaPD. You will also find additional videos on the following topics. What results can you expect from emaPD Plant Designer? What data is relevant for the digital model of the factory? How is the digital model created? How can data be customized in the user interface? How extensive and detailed are the results? And how can a lean layout be designed? We will show you how to determine your transport equipment using the example of gearbox assembly. There is already a project in emaPD Plant Designer for this. However, no transport equipment has been created there yet. The distances between workplaces and warehouses, which are needed to calculate the required transport equipment, are also still missing in the distance table. These should be extracted from the layout, which was previously imported into emaPD Work Designer from a calculated result and customized there. Due to the path map, it contains not only information on the distances between workstations and warehouses in a straight line, but also on the actual driving distances. Here, too, data can be sent to emaPD Plant Designer with a single click on the emaPD logo. Once the data transfer is complete, the project opened in emaPD Plant Designer will now contain an automatically filled distance table. For each required workplace or warehouse transport relationship, the direct distances and routes have been determined using the drawn path map. To calculate how much transport equipment is needed to supply these workplaces, the types of transport equipment to be used must first be created in the library. In the Transport Equipment tab, enter the name of the means of transport and, if applicable, an ID, and indicate whether it is floor-bound. Also specify the average speed and the time required to pick up and set down the transport package. You can then assign the newly created transport equipment to the purchased parts in the Materials tab. In this example, this means that the forklift is to transport the purchased parts from the incoming goods warehouse to the first workplaces and also return the empty containers for these parts from the workplaces back to the empty container warehouse. After that, the library is saved and closed. The transport equipment that has been created is now assigned to the operations in the work plan. In this example, the forklift is to handle all transports within production, except between stations 1 to 6 of the final assembly, since the carriers are passed directly from station to station via a conveyor belt in this area. To do this, the forklift is selected from the drop-down list for all other operations. This means that the forklift transports the finished parts to the next workplace or warehouse and, if necessary, provides the required empty containers. In this way, the forklift is assigned to the operations of all three products. Next, the properties of the transport equipment are defined in the Resources tab. This includes the current number of available transport equipment. If the quantity is entered as 0, the required number of transport equipment is calculated. In addition, the maximum utilization, availability, and MTBF or MTTR can be specified here. Now all the necessary data has been entered to calculate the transport equipment. A calculation is then carried out and one of the calculated results is opened. The Transport Equipment Results tab is now also filled in. As with most other results tabs, the utilization of the calculated transport equipment is displayed graphically on the left side, broken down into transport time, unplanned downtime, and free capacity. On the right-hand side, you will find detailed data, including the calculated number of transport vehicles required and their utilization rates. In this example, 2 forklifts are needed, which would each be utilized by approximately 50% of their capacity. Next to this, additional data on capacity, transport duration, and unplanned downtime is displayed. In addition, the average and maximum number of waiting transport orders, as well as the average waiting time, can be found. Information on the number of full load transports, empty load transports, and empty runs, along with their corresponding operating hours, supplements the results. Furthermore, there is the Transport Coverage Results tab, which was also calculated based on the entered transport equipment. This section lists which transport equipment is to deliver which full load of raw parts or empty containers for finished parts to a specific workplace. It displays the corresponding transport package and its principle of supply, that is, the number of storage locations at the workplace for this item. For the principle of supply, the supply coverage in minutes is displayed, along with the number of transports coming from a warehouse. If these are sometimes delivered with a delay, the number of delays during the planning period and the average duration of the delay are displayed. In this context, only transports from a warehouse, such as an incoming goods warehouse, interim warehouse, or empty container warehouse, can be delayed. Items that are transported directly from one workplace to the next cannot be delivered too late, since the order at the next workplace is not released until the entire production batch is available. By sorting the delays column, you can quickly identify which items or containers are delivered late and how often. This results, in this example, in delays in the delivery of the finished gear wheel output component to the DLZ 630 by 1000 workplace. Since only 2 SLC 4280 containers are provided at a time, the supply coverage is only 4.77 minutes, and of the total 1,189 transports from a warehouse to the workplace, 172 transports are delayed by an average of 0.53 minutes. Here, for example, the principle of supply could be adjusted so that more containers are delivered at once to increase the supply coverage. However, using other transport packages with a higher capacity or using additional transport equipment can also help prevent delays in delivery. If the input values are adjusted accordingly and a new calculation is performed, the impact on delays can be immediately identified and evaluated. Make sure you check out our other videos about emaPlant Designer and all its features. Thank you for your attention.